So இன்னைக்கு நம்ம பார்க்க போற lesson வந்து hydrocarbons. So hydrocarbons are the compounds having carbon and hydrogen. So இதுல வந்து இந்த lesson வந்து நம்ம இத வந்து நாலா பிரிச்சு படிக்கலாம். The first one is alkanes. The second one is alkenes. The next one is alkynes. And the fourth one is aromatic hydrocarbons. Aromatic hydrocarbons. In the mono வந்து it falls under the heading aliphatic hydrocarbons. Okay, so hydrocarbons are of two types. One is aliphatic hydrocarbon, the other one is the aromatic hydrocarbon. Regarding this lesson நம்ம இந்த மாதிரி நாலு பார்ட்டா பிரிச்சு படிச்சோம்னா நமக்கு ஈஸியா இருக்கும். So இன்னைக்கு நம்ம வந்து we are moving to the first part, that is alkanes. So the chemistry of alkanes. So alkanes are saturated hydrocarbons. So what do you mean by saturated அப்படின்னா the carbon atomsக்கு நடுவுல இருக்கிற அந்த bond வந்து எப்படி இருக்கும்னா single bond-ஆ இருக்கும். So saturated hydrocarbons where the bond between the carbon atoms are carbons are singly bonded. Okay, and இதோடைய next வந்து இதோடைய general formula தெரிஞ்சிருக்கணும். It is CnH2n plus 2. Okay, and the first member அதாவது கார்பன் வந்து 1 இருந்ததுன்னா அந்த alkane name என்ன அப்படின்னு பார்த்தோம்னா it is methane and its molecular formula. So if I substitute n is equal to 1, the formula is CH4 and the name is methane. So ஒரு 5 members in alkanes நம்ம தெரிஞ்சுக்கலாம். If it n is equal to 2, it is ethane. If it is 3, it is propane. 4 means butane. 5 means it is pentane. So further, இதோடைய homologous series தெரியும்னா you can verify unit level. Okay, so their successive formulas are C2H6, C3H8, C4H10 and C5H12. Okay, first வந்து ஒரு chemistry of alkanes அப்படின்னா first நம்ம தெரிஞ்சுக்க வேண்டிய விஷயம் என்னன்னா its nomenclature. The IUPAC name, how to give IUPAC name for both IUPAC and common name. Alkanes பொறுத்த வரைக்கும் common name, IUPAC name ரெண்டுமே வந்து ஒண்ணுதான். Second வந்து we must know its methods of preparation. Then next we have to move to its physical properties. And the fourth, chemical properties. And finally uses. So this is the protocol how to learn any organic compound. என்னனாலுமே எந்த ஒரு chemistry of any organic compound போகணும்னா first we must know its nomenclature, followed by preparation, physical property, chemical property and uses. So first நம்ம என்ன பண்ணலாம், let's move to nomenclature. For example, let me take ethane. Ethane formula is 2 carbon atom and you have to fill with hydrogen, CH3. Next, let me take propane. Propane means 3 carbon atom. Let's fill with hydrogens. So only one bond is there, so H3. The second carbon there are 2 bonds, so it is H2. And the third carbon we have only one bond, so this is H3. இதை வந்து நம்ம எப்படி bond line formula எழுதுறது? So bond line formula நமக்கு தெரிஞ்சிருக்கணும். Bond line structure. So 3 carbon, 1, 2, 3. So this is the bond line structure of what's that? Propane. So ஒவ்வொரு பெண்டும் ஒவ்வொரு கார்பன், ஒவ்வொரு பாயிண்ட்டும் ஒவ்வொரு கார்பன் வந்து டினோட் பண்ணும். இது ஒரு C, இது ஒரு C, இது ஒரு C. So ஒரு bond இருக்கிறதுனால it is CH3. இந்த கார்பன்ல 2 bond இருக்கிறதுனால CH2 and this is CH3 and this structure is known as bond line structure. So let's try for Butane. Butane means 4 carbon, H3, H2, H2, H3. So 1, 2, 3, 4. This is the bond line structure for butane. Let me try for pentane. 1, 2, 3, 4, 5. So this is H3, H2, 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 H3. So 1, 2, 3, 4, 5. This is the bond line structure for pentane. Suppose இப்படி ஒரு compound இருக்குன்னு வச்சுக்கோங்க. That is 2-methyl butane. So how to do this? This is the parent. So parent has 4 carbon atom and number the carbon 1, 2, 3, 4. In the second position there is a methyl group. Methyl means 1 carbon. Fill with hydrogens H3, H, H2, H3, H3. So how to draw a bond line structure? First இதுக்கு மட்டும் வரைஞ்சிக்கலாம். 1, 2, 3, 4. Number it. 1, 2, 3, 4. Second வந்து ஒரு methyl group. So you have to draw one bond. You understood? This line indicates it's a carbon at the top. So this is the structure for 2-methyl butane. In your textbook you have one question. Question number 46. So this question is to name the structures of the following alkanes. So question number 46. இதை go through பண்ணலாம். So இங்க 3 compounds கொடுத்திருக்காங்க. The first one is 2,3 dimethyl 6. Again within the bracket 2-methyl propyl decane. So the parent is decane. Decane means there are 10 carbon atoms. Idan decane. First நம்ம வந்து the parent 10 carbon atoms. Let's draw that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me number them. Okay. இங்க வந்து second 2ல ஒரு methyl, 3ல ஒரு methyl group இருக்கு. So 2ல ஒரு methyl, ஃபைனலா நம்ம hydrogens போட்டுக்கலாம். 3ல ஒரு methyl. Methyl means 1 carbon. Methyl means how many carbon? 1 carbon. And how many methyl groups are there? There are 2 methyl groups. In which positions? 2 and 3. So second positionல ஒரு methyl, third positionல ஒரு methyl. Next பாருங்க 6ல வந்து in 6 2-methyl propyl. So here in this group propyl is the parent. So 3 carbon. So propyl means 3 carbon. So let me write 3 carbon in 6th position. And I have to number this propyl also. So how I can give a number like this. அதாவது 6th carbon ஓட connect ஆயிருக்கிற carbon தான் 1. 1. This is 1. This is 2. This is 3. This is propyl. In that propyl, the second position, I am having a methyl group. So how to draw this? Second position la ஒரு methyl group. So methyl means 1 carbon, right? So the propyl chain la second position la ஒரு methyl group இருக்கு. Now you fill with hydrogens, it will be easy for you. Okay, this is the way how to write this. So let me fill with hydrogens. This is H3, 3 bonds is there, so only H. Here only 1 bond, H3. So என்னைக்குமே இந்த terminals எல்லாமே என்னதான் H3. Terminals என்னைக்குமே H3. மற்றபடி நம்ம பார்த்து போடணும். 3 bondsனால H, 2 bonds H2, H2, again 3 bonds H, H2, H2, H2. Here 2 bonds H2, 3 bonds H. So this is the structure for the above compound. Let me move to the second molecule. The second compound is 5-2-ethyl butyl. 2-ethyl butyl. 3,3 dimethyl decane. Dimethyl decane. So first, decane means how many carbon atoms? There are 10 carbon. This is the parent. So methyl means 1 carbon. There are 2 methyl groups in the positions 3 and 3. Again in fifth position I have one butyl group. Butyl means 4 carbon, and in the second position I have an ethyl group. Ethyl means 2 carbon. Okay. So first let me move with decane. So decane again 10 carbon. So I am going to draw a structure having 10 carbon, carbon skeleton with 10 carbon, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So let me number this. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the third position, I have one methyl group. In third position, I have a methyl group. Methyl means 1 carbon. Again in the third position, I have another methyl group. So this is over. Now I am coming to the fifth position. In fifth position, I have a butyl group. Butyl means 4 carbons. In that butyl, and next I have to number this. So the carbon attached to the fifth carbon is numbered as 1. And this is 2, 3 and 4. In this butyl, in the second position, I have a ethyl group. So second la or ethyl. Ethyl na 2 carbon. That's all. So this is the structure. And now let's fill with hydrogens. This is H3, H2. Already 4 bonds is there. Terminals ellame H3 போட்டுடலாம். First அதை complete பண்ணிடலாம். H3, this is H3 and this is H3. Okay. Here there is only 2 bonds. H2, H, H2, 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 H2. Here it is H2, 3 bonds. So H, again H2 and this is also H2. So this is the structure for the second compound. So let me move to the third one. The third one is 5-1,2 dimethyl propyl. Dimethyl propyl 2-methyl nonane. So nonane na 9 carbon. This 9 carbon. Nonane means 9 carbon. In the second position, I have a methyl group. And in the fifth position, I have a propyl group. Propyl means 3 carbon. In propyl, in the first position, I have a methyl group. As well as in the second position also, I am having a methyl group. First, let me draw the 9 carbon atoms. Let me number them. So nonane means 9. And in the second position, there is a methyl group. There is a methyl group. And in the fifth position, I have a propyl group. So 3 carbon. Again, I have to number the side chain. 1, 2, 3. In the first position, I have a methyl group. As well as in the second position, I have a methyl group. Now let's fill with hydrogens. H3, H, H3, all the terminals. Let me fill with H3, H3. This is another terminal. This is another terminal carbon. The remaining, we have to see the number of bonds surrounding it and fill with hydrogens. This is H. This is also H. So this is the nomenclature question which is asked in the book pack. Apart from that, let me check out any evaluate yourself is given. Okay, one evaluate yourself is given and you can go through page number 182. So go through page number 182. There you can see an IUPAC name. The IUPAC name from branched alkenes they have given. You can go through and let me solve that. Evaluate yourself. So the given thing is 4,5 diethyl 3,4,5 trimethyl octane. So octane na enna artham 8 carbon. 8 carbonல இங்க வந்து methyl group இருக்கு. அப்போ 1 carbon. Ethyl group இருக்கு. அப்போ it is 2 carbon. First let me draw the 8 carbons. 5, 6, 7, 8 and then let me number the carbons. Okay. In the 4th position and 5th position there is an ethyl group. 4th la ஒரு ethyl, again 5th la ஒரு ethyl and then 3rd la ஒரு methyl, 4th la ஒரு methyl, 5th la ஒரு methyl. Okay, இது ரெண்டு ethyl, இதெல்லாம் வந்து 3, 4, 5 la methyl group இருக்கு. Now fill with hydrogens. So this is first let us fill all the terminals. CH3, CH3, this is CH3, H3, H3, this is the terminal H3, H3. Now 2 bonds is there, so H2, 3 bonds H, here already 4 bonds is there, 4 bonds is there, again here 2 bonds H2, H2, here 2 bonds is there H2, and this is H2. So, and this is the question what is given for a UPSC name in evaluate yourself. So the first part of alkanes is over. Next we are moving to the preparations of alkanes. Preparation of alkanes. Actually, there are 4 methods of preparing alkanes. The first one is catalytic reduction of unsaturated hydrocarbons. Catalytic reduction of unsaturated hydrocarbons. So first step alkanes are saturated, whereas here we are going to take unsaturated. What do you mean by unsaturated? Means whenever there is a double bond between carbon or a triple bond between carbon, then such hydrocarbons are called unsaturated. So double bonded hydrocarbons are called alkenes and triple bonded hydrocarbons are called alkynes. அப்போ single bond இருந்ததுன்னா அது வந்து என்னது alkanes. Okay, this is alkanes. The other two are alkenes, and these two alkenes and alkynes comes under the category of unsaturated. So what do you mean by unsaturated? There is a double or a triple bond between the carbon atoms. Next, reduction. What do you mean by reduction? So we have learned addition of hydrogen or removal of oxygen. Here what we are going to do is we are going to add hydrogen. The next concept is catalytic. What do you mean by this? Is in the presence of catalyst. The presence of catalyst. So enna panna porom? Alkenes and alkynes we are going to add hydrogen in the presence of catalyst. So the heading is catalytic reduction of unsaturated hydrocarbons. First, let me take an example for an alkene. So alkene another a double bond between two carbon. So render carbon. So the name is eth. Since it's a double bond, ends with the letter ene. So single bond will end with the letter A. Double bond ends with the letters E. Triple bond means ine. Okay. 2 carbon alkene is ethene filled with hydrogens. H2 and this is also H2. To this I am going to add hydrogen in the presence of catalyst. Here the catalyst is platinum. So what is Pt? Platinum. Okay. Now what happens is the bond is cleaved. One hydrogen on the left side, the other hydrogen on the right side. So இங்க CH2 இருக்கு, இதோட ஒரு hydrogen join ஆயிடுச்சு. So it becomes CH3. And the double bond is converted to a single bond. Again CH2 plus H. So this is CH3. So 2 carbon means eth, single bond means ane. So it is ethane. So ethene is converted to ethane. The next, let me have one more example. Let us try with propene. Propene. Prop means 3 carbon, right? Ene means there is a double bond. Now let me fill with hydrogens H2, H, and this is H3 plus hydrogen. இங்க வந்து நான் வந்து catalyst மாத்துறேன். It is nickel, but it must be in a hot condition, 298 Kelvin. So இப்போ என்ன ஆகும்னா the bond is cleaved. எங்க double bond அந்த double bondல தான் போய் hydrogen வந்து add up ஆகும். Single bond அது வந்து it won't add in the single bond, only in the double bond. So this portion becomes CH3. Double bond becomes single bond. Again this portion becomes CH2 and the CH3. So the name of this compound 3 carbon means prop. Single bond na enna name? Ane. So the name is propane. Ethane, propane or the examples for alkanes. So இது வரைக்கும் நம்ம வந்து alkenes வச்சு எப்படி prepare பண்றதுன்னு பார்த்தோம். So from alkenes, how to prepare, how to convert alkenes to alkanes அப்படின்னு பார்த்தோம். Next we are going to see how to convert alkynes to alkanes. Before that, in the nickel catalyst வச்சு பண்ணக்கூடிய இந்த particular equation there is a name. It is known as Sabatier-Sanderson reaction. So this particular reaction is known as Sabatier-Sanderson reaction. So Sabatier-Sanderson reaction means alkene is reduced in the presence of nickel at 298 Kelvin. So next we are going to see an example how alkynes are converted to alkanes. So இதே equation தான் யூஸ் பண்ண போறோம், but double time நம்ம வந்து அந்த procedure repeat பண்ண போறோம். So இங்க என்ன பண்ண போறேன்? I'm going to take a triple bond between the carbon. இங்க only H, and this is known as ethine. Adding hydrogen in the presence of platinum. Okay, so the bond cleaves. H on the left, H on the right. The product is CH2 double bond CH2. So this is nothing but ethene. Again, ethene is added with hydrogen in the presence of platinum. The double bond is cleaved. H on the left, H on the right. The product is CH3 single bond CH3. The name of the compound is ethane. So on this step, it will be repeated. That's all. So this is the preparation of alkanes by catalytic reduction of unsaturated hydrocarbon. So let me move to the second method of preparing alkanes. This preparation from Carboxylic acid. From carboxylic acid. இதில் வந்து ரெண்டு divisions இருக்கு, ரெண்டு விதமான equation இருக்கு. First one is decarboxylation of sodium salt of carboxylic acid. So first we must know what is carboxylic acid. So carboxylic acid, the general formula is COOH. So the well-known carboxylic acid is acetic acid. Acetic acid formula is CH3COOH. So acetic acid உடைய sodium salt decarboxylate பண்ணணும். Decarboxylate என்ன அர்த்தம்னா removal of carbon dioxide. This is known as decarboxylation. So decarboxylate பண்றதுக்கு we should need decarboxylating agent. Decarboxylating agent. Usually what we use is soda lime. Soda lime. So it is a mixture of calcium oxide and sodium hydroxide. So this acts as a decarboxylating agent. So what's the meaning for decarboxylation? Removal of carbon dioxide from sodium salt of carboxylic acid. Sodium salt na enna appadina, the last hydrogen irukku, the replaceable hydrogen is been replaced by sodium. So the name of this compound is sodium acetate. So sodium salt of carboxylic acid, here we are going to take sodium acetate. So the formula for sodium acetate is CH3COONA. Again let me write the name. This is known as sodium acetate, which is the sodium salt of acetic acid. To this I am going to add the soda lime, NaOH, in the presence of CaO. Now what you do is just you box out this. These are just tricks to remember the answer, right? So இதெல்லாமே நீங்க box out பண்ணிட்டீங்கன்னா the H will add to the CH3. Now CH3 will become CH4. So இந்த boxல ரெண்டு Na இருக்கு. So let me write Na2, ஒரு C, மூணு oxygen, O3, Na2CO3. And the name of the compound is methane. So the in the particular equation what is the main thing you have to note down is, here in sodium acetate I have 2 carbon, whereas the alkane what I get is 1 carbon less. So always in this type of reactions, alkane formed will be 1 carbon less than the carboxylic acid. So alkane formed will be 1 carbon less than carboxylic acid. So the textbook la a question கேட்டிருப்பாங்க, is it possible to prepare methane by this method? Is it possible? Is it possible to prepare methane by the above method? It is impossible. Why? The reason is it is not possible. No, impossible. Why? What's the reason? Why it is impossible? Because the alkane what you get will be 1 carbon less. One minute. There is a mistake is there. So not in this method, in the next method, not here. You just eradicate this. Same thing. This question is for the next method. Okay. So this is okay now. So decarboxylation of sodium salt of carboxylic acid. So decarboxylating agent, what you have to use here is soda lime. Decarboxylating agent means soda lime. It is CaO plus NaOH. And then you have to take sodium salt of carboxylic acid. The well-known example is acetic acid. The formula for acetic acid is CH3COOH. Instead of H, I'm using Na there. CH3COONA, that is known as sodium acetate. And then to this, I'm adding the soda lime NaOH in the presence of CaO. And what happens is you will get methane CH4 and the byproduct is Na2CO3. Okay. Now the alkane formed by this method will be one carbon less than the carboxylic acid. I'm moving to the next method of that is Kohl's electrolytic method. So here also I'm going to use the same sodium salt of carboxylic acid CH3COONA, and this here we perform electrolysis. Or sodium acetate undergoes electrolysis. So in electrolysis we know the compounds will be collected in anode and cathode. In anode, what are the things collected? It is CH3CH3. What is it? Ethane and carbon dioxide. Two molecules of carbon dioxide. That is, you have to write two dimerization. Okay, so we have to add two molecules, and this we get it from anode, and then in cathode, what are the products you get now? Here is hydrogen and 2 NaOH. This we get from cathode. This is from cathode. So an anode we get that ethane. And you have an MCQ which is related to this, MCQ 7. The compound that is formed at anode in the electrolysis of an aqueous solution of potassium acetate, aqueous solution of potassium acetate, or, so this is the question. இங்க பாத்தீங்கன்னா இது வந்து இதுக்கு பேர் வந்து sodium acetate. The name of this compound is sodium acetate. And the electrolysis அப்படினாலே என்ன method தான்? Kohl electrolytic method. Here instead of sodium acetate, they are given the potassium acetate. So simple. Instead of Na, I am going to write K. That's all. CH3COOK. This is known as potassium acetate. Same process. Plus H2O on electrolysis. You at anode. What are the things you get is ethane. CH3 bond CH3 plus CO2. In the option, they are given instead of CH3, they are given C2H6. C2H6 plus CO2. This is the right answer for MCQ 7. And actually, in the process, என்ன சொல்வாங்கன்னா dimerization, decarboxylation of two carboxylic acids. So, முதலுக்கும் இதுக்கும் என்ன difference அப்படின்னு பார்த்தீங்கன்னா, this is in the previous one, we have only one sodium salt of carboxylic acid, whereas here we have only one. So it is only one, whereas here I'm taking two carboxylic acids. So this is known as decarboxylation, dimerization. So the right word is decarboxylation, dimerization of two carboxylic acids occurs And mainly this process is used to prepare symmetrical alkanes. Symmetrical alkanes. Symmetrical alkanes na enna arthamna? Alkanes with even number of carbon atoms. Even number of carbon atoms. Okay. Here only the question arises. Methane cannot be prepared by this method. Methane cannot be prepared by this method. That is the question asked in the evaluate yourself. Methane cannot be prepared by this method because already I said you it starts only from ethane because the carboxylic acid what you take will undergo dimerization. So dimerizes to give symmetrical alkane. So methane cannot be prepared by this method. The next, so two preparations is over. The next I am moving to the third preparation. That is preparation from haloalkanes. From haloalkanes. The other name for haloalkanes is alkyl halides. Alkyl halides. Halo na another halogen. Alkanes, alkyl group. The symbol for alkyl group is R. Halides na RX. So this is a general formula for haloalkanes. Under this, we are going to learn three process. The first one is reduction with nascent hydrogen. So what is nascent hydrogen? Reduction already you know. The reduction is nothing but addition of hydrogen. Here we are not going to add directly the hydrogen. Instead of hydrogen, we are going to add nascent hydrogen. So what's the meaning for nascent? Nascent means newborn hydrogen. At that particular time, the hydrogen is being formed. Okay, that hydrogen is going to reduce the haloalkanes. Newborn hydrogen. So what are the so in order to prepare in order to get this nascent hydrogen we need some reducing agents. So how you can get nascent hydrogen? Only from reducing agents. So reducing agents will provide nascent hydrogen. Only that nascent hydrogen is going to reduce the haloalkane. Provide nascent hydrogen. And how to express nascent hydrogen is H within the square bracket. This is nascent hydrogen. So let me list out few reducing agents used as which will provide nascent hydrogen. The first one is zinc HCl. Metal in acid will produce nascent hydrogen. The second one is zinc in acetic acid. This is inorganic acid. This is organic acid. Zinc in acetic acid. This also produce the nascent hydrogen. Then zinc copper couple in ethanol. And then hydride, lithium aluminium hydride. You can use any one of the reducing agent just to produce this nascent hydrogen. So let me take an alkyl halide, ethyl, or let me take propyl chloride. So IUPAC name will be chloropropane. Chloropropane. So propane means how many carbon? 3 carbon, and there is a Cl group, chloride group. Now H3, H2, H2. To this I am going to use two nascent hydrogens. Two nascent hydrogen. The nascent hydrogen is produced by zinc HCl. So what happens is one of the hydrogen replaces the Cl. So the product will be CH3, CH2, and in the H க்கு பதிலா யார் வருவாங்கன்னா ஒரு nascent hydrogen. So this group will become now CH3. நீங்க bond போட்டாலும் ஒண்ணுதான் போடாட்டினாலும் ஒண்ணுதான். Plus இன்னொரு H இருக்கு இல்லையா, that will pick up the Cl. Okay, so the byproduct will be HCl. So one hydrogen comes here and one Cl goes there. So this group will become CH3. I have written here CH3, and this Cl combines with another hydrogen and form HCl. And the name of the product is propane. Next is Wood's reaction. Wood's very important. It will be asked in 2 marks or 3 marks, and also in word problem. Wood's reaction. Wood's reactionல என்ன பண்றோம்னா இதே alkyl halide தான். Let me take what's the name? Methyl bromide. I'm taking 2 molecules of methyl bromide, reverse and write BrCH3 in the presence of metallic sodium. In the presence of with metallic sodium in the presence of dry ether. So இங்க வந்து நம்ம ஒரே ஒரு alkyl halide எடுத்தோம். இங்க ரெண்டு alkyl halide in the presence with metallic sodium in the presence of dry ether. It's very important. Now you box out this, the Br, Na, Br. இத box out பண்ணிட்டு இத ரெண்டையும் join பண்ணிக்கோங்க. So there are 2 CH3 bond CH3 plus write what is inside the box. NaBr. How many NaBr? 2 NaBr. Now the name of the product is ethane. So ஒரு lower halide ல இருந்து ஒரு higher alkane வந்து நமக்கு வந்து என்ன செய்து கிடைக்குது. So lower alkane is converted to a higher alkane, and here you can have a higher alkane with even number of carbon atoms. So mainly this Wood's reaction is used to prepare lower alkanes. Lower na 1 carbon. Lower alkane into higher alkane. Higher alkane means 2 carbon. Into higher alkane with how many carbon atoms? Even number of carbon atoms. With even number of carbon atoms. Next we are going to see a method where you can prepare alkane with odd number of carbon atoms. The name of this reaction is Corey-House mechanism. Corey-House mechanism. Here I am going to take a compound called lithium dimethyl copper. Lithium dimethyl copper. Dimethyl means methyl group twice. Lithium dimethyl copper. To this I'm going to take ethyl bromide. Ethyl bromide. So the formula for ethyl bromide is 2 carbon with 1 Br. So CH3, CH2, Br. Now what happens is it will give propane. The formula for propane is CH3, CH2, CH3. Again methyl copper CH3, Cu, and lithium bromide LiBr. So I get propane here. So this method, in this method, the lower alkane is converted to higher alkane. Lower alkane into higher alkane with odd number of carbon atoms. Odd number of, so 3 carbon, right? Here it is 2 carbon, here it is 3 carbon. Number of carbon atoms. So that's the third division in this preparation, that is from haloalkanes. The first one is the reduction, the second one is the Wood's reaction, and the third one is the Corey-House. Now I am moving to the fourth method of preparing alkanes. It is from Grignard reagent. From Grignard reagent. First on the Grignard reagent, how to prepare Grignard reagent? You should take a halo alkane plus magnesium in the presence of dry ether. You will get alkyl magnesium halide. So haloalkane formula வந்து என்னது RX plus Mg in the presence of dry ether, you will get RMgX. R is the alkyl, Mg is the magnesium, and X is the halide. So this is known as Grignard reagent. So how you call it Grignard reagent? Alkyl magnesium halide. Now let me give an example for a Grignard reagent. Methyl, let me write here, methyl magnesium chloride. So how to prepare this? Methyl chloride plus magnesium in the presence of dry ether, you will get methyl magnesium chloride. So using this Grignard reagent, how we can prepare alkane? So you have to hydrolyze. Hydrolysis of Grignard reagent will give alkanes. So let me take CH3 MgCl. This hydrolysis means you are adding water. HOH. Just box out this like this. So CH3 plus H will give you CH4 plus MgClOH. So the Cl is not directly attached to OH, only OH is attached to Mg. So I am writing in this pattern, and the name of the compound is methane. So there are 4 methods of preparing alkane. The first one is the catalytic reduction of unsaturated hydrocarbon. The second one is from carboxylic acid. So let me give a recap. Preparation of alkanes. The first one is the catalytic. This is the first one. Catalytic reduction of unsaturated hydrocarbons. Okay. So this is the first one. And the second one is decarboxylation of carboxylic acid. Under that we have two. One is decarboxylation of sodium salt of carboxylic acid. Here this is Kohl's electrolytic method. Kohl's electrolytic method. So this is the second one. And the third one is this is the third one, from alkyl halides. Here we come across 3. The first one is reduction with nascent hydrogen. Reduction with nascent hydrogen. The symbol is H within the bracket. The second one is Woods reaction. And the third one is Corey-House mechanism. And the last one is from Grignard reagent. This is the fourth one, from Grignard reagent. So இதில வந்து இந்த ரெண்டுக்கும் உள்ள டிஃபரன்ஸ் தெரிஞ்சிருக்கணும். இங்க என்னன்னா you will get a alkane with one carbon less than the parent. இங்க வந்து என்னன்னா parent விட என்ன இருக்கும்னா it will dimerize, double ஆயிருக்கும். Suppose if I take 2 carbon carboxylic acid, I will get only 1 carbon alkene. இங்க அப்படி கிடையாது. 1 carbon carboxylic acid or 2 carbon carboxylic, 1 carbon எடுத்துட்டீங்கன்னா it will become 2, dimerize ஆகும். Suppose if I take acetic acid, acetic acid வந்து என்ன ஃபார்முலானா CH3COO, இது வந்து CO2 வெளியேறிடும். Just I'm meaning what is one carbon is the alkyl group carbon. It has only one carbon, that will be dimerizes to ethane, CH3CH3. Okay, don't count this carbon which is present in the carboxylic acid. அது விட்டுருங்க, just think about the carbon in the alkyl group, that will dimerize. And coming to this here, the reduction with nascent hydrogen, you must know the reducing agents, it's very important. Which reaction you will get a higher alkane with even number of carbon atom. In Corey house, you get a higher alkane with odd number of carbon atom. So that is the preparation of alkenes. Coming to MCQs. So MCQ2, if you go through MCQ2, the reaction is given C2H5Br plus 2Na gives C4H10 plus 2NaBr. What is the name of this reaction? என்னைக்கெல்லாம் இந்த Na வந்துட்டாலே அது என்ன reaction? Woods reaction. அதே மாதிரி பாருங்க, அது வந்து even number of alkene, even number of carbon atoms இருக்கு, even number of carbon atom. So the reaction is Woods reaction. The next MCQ is MCQ3. They are given an alkyl bromide reacts with sodium in ether. So sodium in ether naal enna Woods reaction, and it forms 4,5 diethyl octane. What is compound A? So 4,5 diethyl octane product கொடுத்துட்டாங்க, அவங்க வந்து ரியாக்டன்ட் கேட்குறாங்க. இது எப்படி கண்டுபிடிக்கிறது? ஃபர்ஸ்ட் இந்த ப்ராடக்டோட ஃபார்முலா எழுதலாம். 6, 7, 8. 4ல ஒரு ethyl group இருக்கு, அதே மாதிரி 5ல ஒரு ethyl group இருக்கு. So fill with hydrogens H3, H2, H2, H, H, H2, H2, H3, again H2, H3, H2, H3. இது பார்த்தீங்கன்னா இது ஒரு சிமெட்ரிக்கல் ஆல்கேன். இப்படி ரெண்டா பிரிச்சிங்கன்னா ரெண்டா பிரியும். சிமெட்ரிக்கல் ஆல்கேன்னாலே என்ன ரியாக்ஷன் தான்? உட்ஸ் ரியாக்ஷன் தான். அப்போ இந்த இடத்துல தான் யார் இருப்பாங்க? ஹாலைட் இருக்கணும். The halide must be substituted here. So இந்த particular part மட்டும் நான் எடுத்து எழுதுறேன். So let me write this alone. CH3, CH2, CH2, CH, ஏதாவது ஒரு halide போட்டுக்கலாம், Cl. இங்க என்ன இருக்குன்னா CH2, CH3. புக்ல வந்து என்ன கொடுத்துருக்காங்கன்னா Br கொடுத்துருக்காங்க. Let me take Br. Okay. Now, how to find this answer? இப்போ பார்த்தீங்கன்னா CH3, இந்த CH2 எப்படி கொடுத்துருக்காங்கன்னா CH2 twice, right? So this ரெண்டு CH2 இந்த மாதிரி CH2 twice கொடுத்துருக்காங்க. Then CH, Br is written within the bracket, means the CH, Br belongs to this carbon. Again, you can continue the chain. CH2, CH3. What do you mean by this? Br is not directly attached to this carbon. Br belongs to this carbon, Okay, so option D is the right one. The next one is question number 41. Question number 41. This is also regarding preparation of alkanes. How will you convert ethyl chloride? ரொம்ப simple question. Ethyl chloride into, first one is ethane. So ethyl na enna artham? 2 carbon. Chloride means 1 Cl. So this we can achieve by adding nascent hydrogen, 2 nascent hydrogen. And then our reducing agent is zinc and HCl. The product is ethane, CH3, CH3, plus HCl. The second one is N-butane. N-butane dimerize பண்ணனும். Dimerize பண்ணனும்னா இது வந்து even number. Butane எத்தனை carbon? 4 carbon. அப்போ இது வந்து dimerize பண்ணனும். அப்போ என்ன process correct அப்படின்னா பியூட்டேன்ல பாதியா குறைச்சிங்கன்னா ரெண்டு கார்பன் 4 கார்பன் அதோட பாதி வந்து 2 கார்பன். ஸோ 2 கார்பன் ஹாலைடு எடுத்துக்கிறேன், Br எடுத்துக்கிறேன், plus 2Na. Again I am reversing BrCC in the presence of dry ether. Fill with hydrogens. This is ethyl bromide. Ethyl bromide. So box out Br and Na. So the answer is இது ரெண்டையும் join பண்ணிக்கணும். CH3, CH2, CH2, CH3 plus 2NaBr. இதுதான் என்னது N-butane. N stands for straight line. All the four are normal. All the four are arranged in a normal way, straight chain. So this is the answer, N-butane. So that's N sub. And one more question is there. Let me write here. Question number 47. Question number 47. How will you prepare propane from sodium salt of fatty acid? So ethane prepare பண்றதுக்கு acetic acid தேவை. அப்போ propane prepare பண்றதுக்கு 3 carbon acid, CH3, CH2, CH2. Again you have to write COO, Na. In the presence of NaOH, CaO. So box out. So you'll get now propane. CH3, CH2, CH3 plus Na2, CO3. So the name of this compound is sodium propionate. Propionate, you will get propane. Okay. So these are the questions given under the preparation of alkenes in your book bag. Go through and learn well the preparations of hydrocarbons. Thank you.